Good. Welcome in today's discussion. As I said, this week we were privileged to have comrades to engage in these two units, that is mathematics and accounting. And over the week we've focused on functions. So I want us to also to share to our fellow comrades who are maybe far away or they never get time to be with us. So this video will be benefit you in regards to the two. We were looking in now into functions, and we have tackled on the linear functions, that is on the straight line. And we want now today to also focus on the linear inequality. Linear inequality. Linear inequality, and see how it will take us through. So today, let us focus on the what? Linear inequality. Linear inequality. Good. The linear inequality, what we are going to do, we are going to have to solve to see there is a single linear inequality and compound linear inequality, and be able to know how to present on number line. So the objective here is for us to know how to can solve the single linear inequality, both, and also common compound inequality, and be able to present on the number line. Good. So we will go direct to the question that we might meet in an exam scenario. So exam style question. Exam style question in this area, you realize we will have one, consider the linear inequality. So question one that I'm going to handle today. One, consider the linear inequality. Consider the linear inequality 2x minus 3 less than 5x plus 2. 5x plus 2. So that is the first question we are going to solve here. First question that we are going to solve. So we have been told that we solve the linear inequality, and we express the solution. We express the solution to the number line. So step one in this question, what we'll do, we have to put the like term together. The first step, put the like term together. How do you put the like term together here? Like term together, we are going to group for those variable of x, and those that are constant values, they get to the other side. So let us group the like terms together. So one, I will bring the 2x this side, 5x will come this side, then that 2 will go the other side, so it will be 2 plus 3. So that is how to group the like terms. The first step is to group the like terms together. Make sure that you group the like terms together. Good. The second step now, we can solve now. We can solve. Good. So you have seen the other thing I want to emphasize here. You have realized when it crosses if this value, you see it was there with a positive, when it crosses this side, it will be what? Let's see, 2. 2 remains. This was a negative here. When it crosses this sign, the sign changes, positive. And this one, it was positive. When it crosses this sign here, it will be negative. Good. So let's do the expression. 2 minus this, it will be negative. 3x less than. Then this one will be what? 5. Good. So we have now to do what? To determine. We have to determine the value of. We have to determine the value of x. We have to determine the value of x there. Now to remain with the x alone, you'll have to divide both sides by what? You have to divide both sides by -3. -3. So there's an interesting part here I want you to note, and it's where students may get always wrong. When you divide both sides with a negative sign, the value that you are dividing from, you want to eliminate to remain with the x, but you are dividing with a negative, there's something will happen whereby this sign here, this inequality will change. This inequality will change. So I had intentional. I had to choose this question intentionally, so that to explain this to students, so that you cannot went ahead and fail in an exam. You can. So when I say this will change it, because it will be now, it will be x. The answer must be x greater than 5, -5/3. So you see the sign has changed. The sign has changed to, it was less than, that's gone to the greater than. That's gone to greater than. Good, greater than. Now, if if we could have divided them, maybe say with just a positive, the sign could have remained the same. It could be x less than 5/3 without a negative. So not that one. So you can put somewhere just NB, that when you divide with a negative sign, the sign will do what? Sign will change. This area is very tricky part, where you will realize your students don't change the sign. So you'll come out that you are very happy, you have gotten the point, but at the end of the day, you'll realize you have failed. Good. Now, we have now this. So you'll get another question that always comes this, that express before you go to the number line. Express the solution set. Express the solution set. Express the solution set in interval notation. In interval notation. Good. So we want to express this x less than -5/3 into interval notation. So in case you have been given that, what you'll do is just simple. You'll say, for this case, like you can see, because this is just a simple or a single compound inequality, so it will be just simple. You can just write negative there, and then finish 1 and a comma. That is how to express that, -5/3. So this will be your answer. This will be your answer. So part 3 on that question. You'll be told, graph the solution on the number line. Graph the solution. Graph the solution on the number line. I think all of us, we are aware of the number line. So what we'll do, just a matter of drawing the number line here, and then I see how we'll. Good. And that, maybe go this side, we can say this is 0, this is 1, maybe 2. Then you have -1, -2, -3, -4. We have -5. Good. So 5 divided by 3 is what? 5 divided by 3 is what? 1.6. 1.6. This is just the same as 1.6. 5/3, just the same as what? 1.7 or 6. 1.7. 1.7. -1.7. So on this number line, we want to show that we are expressing. So what we are showing, we want to express this one here on the number line. Good. On the number line. So to express that on number line, so we'll come here where -1.7 can be where? Can be somewhere here. Can be somewhere here. Good. So Remember, I always also insist this, not somewhere, that if you see this, and there is this greater than or is equals to, so these two signs, when you go on the number line, like let's say we have said that one, when you go on the number line, this one, you'll just put something, this one will show this one is not inclusive. This one is not inclusive. But if you see this, you'll have to put that strong dot there. This one shows that this even -5, 3 is inclusive. So if I come here now, I'll just put a small circle. Yes, a small circle without putting a strong dot. Then it is what? X is greater than. X is greater than -5/3. So it's greater than, should come where? X is greater than -5/3. So we'll come in that direction. So we have plotted here, in short, we have plotted -5/3. -5/3. So that is how we present on number line. That is how we present on number line. Very simple, and you are good to go. Very simple, and you are good to go. Good. Very simple. Very simple, and you are good to go. So another one. So let us now solve the what? Let us solve the compound inequality and present on number line. The same thing. Let us solve the compound inequality. This was just a single inequality. When I say single inequality, just have the only one inequality in the linear inequality in this question we have been given. But the compound inequality, now we are going to solve the one that has got combined inequality, which we can have either less than or equal to, and with the other side we can have maybe more than or equal to, or we can have less than, then the other side we have greater than. So let's see how we can solve that, and also do it. Present on number line the same solution. Good. Good. Now, so you'll get another exam type question that can come there. So another question 2, question quiz 2 that we can solve. And this is another type exam question. Solve the compound inequality. Solve the compound inequality. Solve the compound inequality. Solve the compound inequality. You have been given 3 less than 2x minus 1, 2x minus 1 less than or equal to 7. A very easy question. Good. The only thing they have added there is what? They have put, there are 2 inequality there compared to what we have solved in the other part. So this one, what we normally do, you just have to go step by step. So I want to show you how we can do this. So step one, I will wish you to do what? To add. You see, focus on this part here. I know very well there is this question I've solved in one of the videos, but I've used another formula. This one, I'm going to use another way on how we can approach this one now. In the other video, I was dealing with this part separately. The one part from here to here separate, another one from here, the other one from here to here separate. But this one I want us now to solve in a different way. Now, how do we solve this one? One, focus here. We have -1 constant here in the middle. So we want to add this constant this side, we add this side, then we add here also. The aim is to make sure we remain with just 2x in the middle and eliminate this. In case we could be having here +1, you could have done what? You could have -1 here, you minus on the other side, and you minus the other side. So the aim is to remain with 2x in the middle. So what? Let's solve. So let's add. So you can say add 1 to all parts. Add 1 to all parts. This question is a 4, I think 6 marks question. So you can have here, you can even put 6 marks. 6 marks. Yes, this is a question of 6 marks. So pay attention. So what you'll do, it will be now 1 plus 3 less than 2x minus 1 plus 1 less than or equal to 7 plus 1. So you have seen I've added 1 on both sides as I had explained before. I've added 1 on both sides. So if now we solve now, it will be now become, here it will become now, this becomes now, so you can say this becomes now, here it will be 4 less than, if negative 1 plus 1, it will eliminate each other, meaning negative 1 plus 1 is 0. So it will remain here 2x, then less than or equal to 8. Good. So another way, now we are there now. Next, we have to remain with the now x in the middle. We have to remain x in the middle by dividing through by 2. So we have to divide by 2. So we have to remain with the x, remain in the x. So we can say remain where x in middle, middle part, the middle part, by dividing 2 all through, dividing 2 all through. So meaning I'm going to divide 2 all through it here 2, then 2, good. So here it will be 1, here 2, here it will go, here it will be 4. So I will have 2 less than x greater than to 4. Good. So you see, this becomes now our answer. Because at the end of the day, we wanted to remain with the x in the middle, and we remain with the x in the middle, and we'll have solved that. We have solved that compound inequality. Just simple as that. Just simple as that. So the same thing we did to the other one. Let us we express the solution in internal notation, the values that are inclusive in that interval, in this interval. So another part B on this question will be told, part 2 on this question will be told, express the solution, in internal notation. Express the solution in internal notation. So to express the solution in internal notation for 2 less than x less than this 4 is equals to, it will be what? Internal notation will be 2, 4. It is in the range of that. So that is how you'll give your values after you have expressed that. So the last question now, it will be now, you do what? We graph the solution on the number line, part 3 on that question. Graph the solution on the number line. Graph the solution on the number line. Good. So we are going to graph a solution, this one, on the number line. So you'd have to draw your number line that way. Then let it be here 0. So here 1, 2, 3, 4, 5, 6, and then here -1, -2, -3. Good. So we start with plotting. Remember what I told you the other time, that you have to know this, that if you are going on the number line and you have maybe something like this, greater than, or this one, and you want to present, remember the number line, if it's this way, let's say here we have 1, you will do what? You will do this to show it is not inclusive. That value is not inclusive. But in case it is maybe greater than, or that way, or that way, if you go on the number line, let's say here we have 2, it will be, you'll put a strong dot to show that value is inclusive. So those are the basics you have to know while you are going to on the number line. So here now, x is less than 2, x is less than 2, x is less than 2, I will come here, x is less than 2, I'll put that. X is less than 2, I'll put that, a circle. Then x is less than or equal to 4. X is less than or equal to 4. So when they say x is less than or equal to 4, you put like a strong, meaning this 4 is even inclusive. So it is 4, 3 is inclusive. Good. So that is how we do. So you draw that, it touches there as it continues. Good. So meaning we are heading on this direction. Good. So that is how we do the linear inequality. Very easy. That is how we do the linear inequality. Linear inequalities. Linear inequalities, both the single and both the compound. So that is how we will be doing that. In case you meet a problem on the same, as I said, this is just to help one another. Just drop the comment in the comment section, and I'll be able to explain that when we meet in our discussion. But if you need more, even more of the discussion, don't fail to reach in my comment section so that I can include you in one of the sessions we normally have in the course of the week. Good. So that is done, said and done on the linear inequalities. We want now to look into the quadratic equation. We solved 2 questions there. Then we look into the polynomials. Then we'll have closed the chapter of the functions, Good. So for today, bye-bye. Remember to share and subscribe to the channel and share to others so that they can continue benefiting on the same. So may God bless you. May God continue being with you. Bye-bye.